Jai Hind. So, in today's lecture, we are going to discuss topics from Unit 5. So, the first is the switchgear. It is an apparatus used for switching, controlling and protecting the electrical circuit, right? We need some kind of apparatus to protect our electrical circuit, and it includes wide range of switching devices. It also includes the combination of these devices with associated control, measuring, protecting and regulating equipment. The switchgear devices and their assemblies are used in connection with the generation, transmission, distribution, conversion in electrical engineering. Now, there are different types of switchgear. The first is LT switchgear. So, in this, it is generally rated up to 1000 volt AC to 1500 volt AC. The commonly used low voltage devices include oil circuit breaker, in short we write it as OCBs, air circuit breaker, that is ACB, switch fuse unit, that is SFUs, offload isolators, HRC fuses, earth leakage circuit breakers, residual current protective devices, miniature circuit devices and molded case circuit breaker, that is MCCB, etc. All these comes under LT switchgear. All the accessories required to protect the LT system. The most common use of this is in LV distribution board. So, this is the switch fuse unit you must have seen in your houses. These switch fuse unit, here this is a closing link, here you can see the frame, this is the frame. Then these are the fuses, you can see the 3 fuses are there. Then disconnecting link is here, operating handle here, then the cover, this is the cover, and the rubber rings, these are the rubber rings. So, and this is TP IC switch, this is DP IC switch. So, these are the switch fuse unit you must have seen in your houses. Now, but now we don't use this SFU. Instead of this SFU, we use MCBs. So, this now what is this switch fuse unit? So, switch fuse is a combined unit and is known as an iron-clad switch, right? Being made of iron. It may be double pole for controlling single phase, 2-wire circuit, or triple pole for controlling 3-phase, 3-wire circuit, or triple pole with neutral link for controlling 3-phase AC, or 4-wire circuit. The respective switches are known as double pole ironclad, that is DPIC, which we have seen in previous slide. Then triple pole ironclad, TPIC, and triple pole with neutral link ironclad switches. Then now coming to the MCB. So, these are more sensitive than the SFU. So, MCBs are more sensitive than SFUs, and nowadays we use MCBs in our houses. Protection against overcurrent and short circuit for the thermal operation, is achieved when a bimetallic strip which deflects when heated by any overcurrent flowing through it, and in doing so releases the mechanism that causes the contact to open. So, there is a bimetallic strip which bends when it gets heated because of the overcurrent. So, here you can see that this is a bimetallic strip, and this when there is a heating or when there is a overcurrent flowing through this strip, there will be heating. So, this bimetallic strip, you can see it bends here. So, when it's bent here, you can see now this latch will get open. So, when this latch will get open, the connection will be, it will get disconnected, right? So, it will open the contact here. So, this is how this is the mechanism of the MCB. Then here, this is a more clear picture of, you can see, or you can see this is the cross section of MCB, where you can see here this is the power terminal, here this is the bimetallic strip, here you can see this is the bimetallic strip here, and this is the latch point. So, when this bimetallic strip get heated, it will bend, and here this is a trip coil, right? And the operating lever which is outside of this case. So, then the arc splitter, moving contacts here, arc runner, and here we have a fixed connect. Now, coming to the MCCB. So, this is molded case circuit breaker, and it is a type of electrical protection device that can be used for wide range of voltage frequencies of both 50 Hz and 60 Hz. And the main distinction between the molded case and miniature circuit breaker are that MCCB can have current rating up to 2500 ampere, and its strip setting are normally adjustable. We can adjust its stripping, like it's adjustable. So MCCBs are much larger than MCB, and MCCB has three main functions. The three main functions are protection against overload, then protection against electrical fault, and switching a circuit on and off. And this is a less common function of this circuit breaker, but they can be used for that purpose if there is not an adequate manual switch, right? So we can use there. Then the wide range of current rating available for this molded case circuit breaker allows them to be used in a wide variety of applications, and MCCBs are available with current rating that range from low values such as 15 amperes to industrial ratings such as 2500 amperes. And this allowed them to be used in both low power and high power applications. So MCCB has had wide area of application as compared to MCB. And one more thing which differentiated from MCB is that here there is a setting, we can its trip setting can be adjustable. Now comes the operating mechanism of this MCCB. So at its core, the protection mechanism employed by MCCB is based on the same physical principle used by all type of thermal magnetic circuit breaker, and the overall protection is accomplished by means of a thermal mechanism here. MCCB have bimetallic contact that expands and contracts in response to change in temperature. In MCB also we have seen that there is a bimetallic strip was there, and in this also we have a bimetallic contact that extends and contract on the while it depends on the change of temperature. So under normal operating conditions, the contact allows electric current through the MCCB. So however, as soon as the current exceeds the adjustable trip value, the contact will start to heat and expand until the circuit is interrupted, right? So then it will interrupt the circuit. And now on the other hand, fault protection is accomplished with electromagnetic induction, and the response is instant. Fault current should be interrupt immediately, no matter if their duration is short or long. It should be interrupted immediately. So whenever a fault occurs, the extremely high current induces a magnetic field in a solenoid coil located inside the breaker, and this magnetic induction trips a contact and current is interrupted, right? So as a complement to the magnetic protection mechanism, MCCB have internal arc dissipation measure to facilitate interruption. Now coming to the next type, that is ELCB, that is earth leakage circuit breaker. It is a device that provides protection against earth leakage, and there are two types. The first one is current operated earth leakage circuit breaker, and the second one is voltage operated earth leakage circuit breaker. So first we will see the current operated earth leakage circuit breaker. So it is used when the product of the operating current in amperes and the earth loop impedance in ohms does not exceed 40. Such circuit breaker is used where consumer's earthing terminal is connected to a suitable earth electrode, right? Now next, the current operated earth leakage circuit breaker. Here the current operated earth leakage circuit breaker is applied to a 3-phase 3-wire circuit. We applied it to a 3-phase 3-wire circuit, and in normal condition, when there is no earth leakage, the algebraic sum of the current in the 3 coil of the current transformer is 0. Here we can see 3 coils, right, is 0, and no current flows through the trip coil. So there will be no current through this trip coil. So in case of any earth leakage, the current are unbalanced and the trip coil is energized. So if there is any kind of unbalancing, so this trip coil will get energized and the circuit breaker is tripped, right? The next is the voltage operated earth leakage circuit breaker. So it is suitable for use when the earth loop impedance exceeds the value applicable to fuses or excess current circuit breaker or to current operated earth leakage circuit breaker. So when the voltage between the earth continuity conductor and earth electrode rises to sufficient value, the trip coil will carry the required current to trip the circuit breaker. And with such a circuit breaker, the earth lead between the trip coil and the earth electrode must be insulated. And in addition, the earth electrode must be placed outside the resistance area of any parallel earth which may exist. Now coming to the air circuit breaker. So in an air circuit breaker, it consists of fixed and moving contacts that are enclosed in an arcuate chamber having air as an arc quenching medium. And these circuit breakers are usually used for low voltage application, that is up to 1000 volt. Its current rating ranges from 500 ampere to 10,000 ampere. The air circuit breaker employs a high resistance interruption method for the arc extension. The resistance of the arc is rapidly increased to a high value during the opening of a circuit breaker in fault or normal operating conditions, such as source voltage becomes incapable to maintain arc voltage. Arc resistance can be increased by many methods such as cooling the arc, lengthening the arc, reducing the cross section of the arc and splitting the arc. So here we can see the contact is closed here, and here you can see that the contact is open here. Now coming to the application of air circuit breaker. So air circuit breaker are mainly used for low voltage and low or high current applications. Then air circuit breakers, are also used mostly in indoor low and medium voltage electrical installation such as power control cubicles and motor control cubicles. Air circuit breakers are preferred for applications where there is a high risk of fire hazards, as ACBs have a very short arcing time, right? Then air circuit breaker are used for motor and capacitor starting and protection applications, as they are most suitable for frequent and high speed operation. Air blast type circuit breaker are widely used in railway electrifications. So these are the applications of air circuit breakers. Now coming to the next topic, that is earthing, right? So what is this earthing? So basically the earthing is the process of transferring the immediate discharge of the electrical energy directly to the earth by the help of low resistance wire is known as the electrical earthing. Now what is the necessity of good earthing, right? So to save human life from danger of electrical shock or death by blowing a fuse, that is to provide an alternative path for the fault current to flow so that it will not endanger the user. To protect buildings, machinery and appliances under fault condition, that is to ensure that all exposed conductive parts do not reach the dangerous potential. And to provide safe path to dissipate lightning and short circuit currents, to provide a stable platform for operation of sensitive electronic equipment. that is to maintain the voltage at any part of an electrical system at a known value so as to prevent overcurrent or excessive voltage on the appliances or equipment. So here we can see that this is a live wire, this is a neutral wire, and this is the fault current is passes through the earthing gear. So now coming to the types of earthing. So there are different types of earthing, that is pipe earthing, plate earthing, rod earthing and strip earthing. So let's see these different types. So this is the structure of pipe earthing. All the dimensions are mentioned here in the diagram. So basically the pipe earthing is best form of earthing. It is cheap in system of earthing, as this GI pipe of 38 mm diameter and 2 meter length is embedded vertically in ground, as in previous slide you can see, right, is embedded in this ground. So as earth electrode, but depth depends on the soil conditions. So wire is embedded up to the wet soil. The earth wire is fastened to the top section of the pipe with nut and bolts, and the pit area around the pipe is filled with salt and coal mixture for improving soil condition and efficiency of earthing system. So it can take heavy leakage current for same electrode size in comparison to plate earthing. If you compare with the plate earthing, the earth wire connections with GI pipe being above the ground level can be checked for carrying out continuity test, right? We can here check it for the continuity test, and when desired, where it is difficult for plate earthing. But if you compare with the plate earthing, it is difficult in that case. So in summer season, to have effective earthing, 3 or 4 bucket of water is put through the funnel for better continuity of earthing in this method. Now coming to the plate earthing. In plate earthing, an earthing plate either of copper of dimension 60 into 60 into 3, of galvanized iron of dimension 60 into 60 into 6 mm is buried into the ground with its face vertical at a depth and not less than 3 meters from the ground. Here you can see, here we place a plate. So the earth plate is inserted into auxiliary layer of coal and salt for a minimum thickness of 15 centimeter. The earth wire, GI or copper wire, is tightly bolted to an earth plate with the help of nut or bolt, and the copper plate and copper wire are usually not employed for grounding purpose because of their higher cost. So now earthing through water mains. In this type of earthing, the GI or copper wire are connected to the water mains with the help of steel binding wire, which is fixed on copper lead as it is shown in this figure. The water pipe is made up of metal and it is placed below the surface of the ground, that is directly connected to earth. The fault current flow through the GI or copper wire is directly get earthed through the water pipe, right? Here we can see the water pipe. So this is all about the switch gears and the earthing system, and these are the references. So there are different kind of switch gears which we have seen: the SFU unit, the MCB unit, the MCCB. We have seen the difference between the MCB and MCCB, right? We can see that in MCCB the tripping can be are adjustable, but in MCB the tripping is not adjustable. And we have seen the ELCB, then ACB, air circuit breaker. Then we have seen the earthing, what is earthing, then the importance of earthing, why it is required to save the human being from the shock, and then we have seen the different types of earthing we have discussed in this lecture. That's all. Thank you.